We are talking about circle and circumference and measuring angles and arcs. And we want to identify and use parts of a circle, identify central angles, major arcs, minor arcs, and semicircles, and find their measure. And here are a couple more terms that we need to pay attention to. So we have inscribed, and the polygon is inscribed in the circle. So inscribed, we can cut this word into two parts right here, where in is inside, and scribed or scribe meaning to write. So the polygon is inscribed in the circle, or it's written inside the circle. Circumscribed, the circle is circumscribed about the polygon. So we can divide this word as well. And right here, we can split it. And we have circum, and that means around. And scribed, still meaning right. So the circle is written around the polygon. So the same two figures, but can be described two different ways. You can either describe it by the way the polygon was drawn inside the other circle, or inscribed, or you can write it how the circle was drawn around the outside of the polygon. Both are correct. We have a couple more examples to talk about, a couple more definitions to introduce. So on the next page, we have a few things. Name the parts from the image to the right. So the center of this drawing is called point P. Then we want name the tangent. In this case, the tangent is a line. So the tangent is a line that touches but doesn't go through. And so we have it right here, and you can name it three different ways. You could call it line EQ. You could call it line QE, or you could call it line M. So any one of those are acceptable names for the tangent line. The diameter, we only have one of those in this case, and that is going to be HG, and that's a line segment. HG is a line segment, and there's only one that has two endpoints on the circle and includes the midpoint. So that's our diameter. Point of tangency. The point of tangency is where the tangent line intersects the circle, and that's going to be at point Q. Any chord. So we have three chords on here. We have the chord AB, that can be written AB or BA. We have the chord CD, where it has points right there, so it's line segment CD. And we have HG, which is the diameter, but it is still a chord. The next, we have what is a secant, and a secant has to intersect the circle at two locations. So for this one, we have two locations for the line, or for two names for the line. We have line CD, line DC, or line N. and that represents the secant where it intersects 2 times, and it also is a line. And then the last one is radius, and we have a few radii here. We have the radii PH, so we have line segment PH, we have line segment PG, and we have line segment PQ. Those are all radii. So we got a radius, and a radius. Those are all the chords that go through the center and connect to the outside of the circle. Now we have a central angle, and a central angle is an angle whose vertex is the center of a circle. So if we're looking at our example right here, our central angle, we would call it angle APJ. So that's going to be the central angle over there is going to be called angle APJ. Now we could also say, because it's right there, is 78 degrees, it says the measure of angle APJ is equal to 78 degrees. The measure of a central angle is the same as the measure of its arc. So just remember, central, center, same. So right here, 78 degrees is the central angle, and the arc is also 78 degrees. So the measure of the arc AJ is also equal to 78 degrees. And the arc AJ is the arc that goes around the circle from A to J. So I have a question here. What is the sum of the measure of the central angles of a circle? So basically it says, how many degrees are there in the entire circle? And if we had a bunch of different angles, if we started at A and we went all the way around and got back to A, or if we started at line segment PA and we went all the way around the circle and we got back to line segment PA, that would be 360 degrees. So now we have a couple distinctions. We talked about arcs, and arc is just how far you're going around the circle, but now we can talk about a minor arc and a major arc. So a minor arc is an arc with a measure between 0 and 180 degrees. So it can't be 0 and it can't be 180 degrees, labeled by 2 or 3 points. So the measure of the minor arc is equal to the measure of the arc's central angle. So right here, the minor arc is going to be the same as above. The measure of arc AJ is equal to 78 degrees. And that is the minor arc, which is located right here. The major arc is an arc with a measure between 180 degrees and 360 degrees, and you can only label with 3 points. So the measure of the arc is 360 degrees minus the measure of the minor arc. So in this case, the major arc that we're talking about is from A going around through E, all the way around, keep going all the way around to J. So that's the major arc. So we have major here, and then we have minor here. So the measure, and remember the major arc has to be labeled by 3 points. So we're going to call this one AEJ. So the measure of major arc AEJ is equal to, in this case, it's the 360 degrees minus the minor arc, which we said was 78 degrees. So the measure of major arc AEJ is equal to 228 degrees, 282 degrees. So we have a couple more things to introduce, a couple more topics to introduce. And we have a semicircle, an arc whose measure is 180 degrees. So a minor arc had to be between 0 but not including 180, and a major does not include 180 and does not include 360. So a semicircle, that's the whose measure is 180 degrees. Endpoints are those of the diameter. Okay, so, and when we name this one, we have the diameter AJ, that's the diameter. So the diameter is equal to, or is named the line segment AJ. So those have to be the endpoints of the semicircle. In this case, the semicircle that we're talking about, and remember we have to name it with 3 points, it's going to be A, D, J. So all the points that we go through if we're going to draw around. So this would be A, D, J with an arc there. Adjacent arcs are arcs in a circle that have exactly 1 point in common. So here we have 2 arcs. We have arc HJ right there. And then we have arc JK. And so those are adjacent arcs. Next, we have arc addition postulate. The measure of an arc formed by 2 adjacent is the sum of the measures of the 2 arcs. So here we have the major, no, this isn't the major arc, but we have the minor arc, XYZ right here. So that's the full arc right there of all those 2 smaller arcs. Then we have plus the measure of XY, of arc XY. So XY is this arc right here, plus YZ. Arc YZ and arc YZ is right there. And so this is the same as like angle addition postulate or segment addition postulate, but this time we're just talking about arcs. In the same circle or in congruent circles, 2 minor arcs are congruent if and only if their central angles are congruent. So in this case, it says if angle 1 is congruent to angle 2, so we say angle 2 is congruent to angle 1, then FG, which is right here, that arc FG, is congruent to arc HJ. Then you can say it the other way around. So this one says if angles are congruent, then the arcs that those angles make are congruent. The other way that says if arcs are congruent, then the angles that make those arcs are also congruent. Congruent arcs are two arcs in the same circle or in congruent circles that have the same measure.